Yeah, man. Yo, you know what I'm saying? Yeah. Let's do this up front. Yeah, man. All right, guys. There you are. There's the camera. All right. So, morning, everyone. This is DJ Raul keeping it cool once again. You know what I'm saying? No pain, no gain. You know what I'm saying? All right. So, yeah, what you're hearing in the background is basically a track, track built by yours truly. You know what I'm saying? Keeping it cool. Yeah. So, this morning, actually, the focus for students is on what you're seeing on the screen, which is significant figures. So last week I would have discussed what significant figures were, and going back through those notes, believe this is an assignment that was given from last week, but I want to cement a few things before I go through this assignment. All right, now this is for the benefit of the grade 9 students at Belfield High School, and of course I'm their teacher, Mr. Finlayson, aka DJ Raul, keeping it cool. Anyway, so yeah, back to this now. So what we have here, significant figures, the homework, but again we still want to reinforce some concepts here. And looking back at what was done, and if I could just zoom in a bit, yeah. What we have here is the question, the instructions was to what? Please write the correct number of significant figures in each number. All right, so that was the instruction, and so here you have quite a few of them. Believe there are about 18 questions here, and I did the first 4 after going through the lesson. Are going through the instructions as to what what significant figures are, and then you were given this to solve. So when I recap and go through this shortly. All right. So what I do now? So when I try and send this link, I'm gonna copy this link, and in class. You can join the class from there. All right, so once again, DJ Raul keeping it cool. Once again, let's send the announcement to the class here, and all right, so yeah, students can join at this link. All right, so yeah, I'm gonna just ask him to please join the class at this thing. Yeah, so so this would have begun before. All right, so yeah, so that's a shout out. This is the link for students to join class. So I just posted it in the classroom, Google Classroom, as stated by the ministry here, which it's a wonderful initiative by the ministry to have a common platform that a school can use to upload information, videos, everything. It's very wide. So, and on that note, persons are saying, well, the face-to-face is better, pushing to go back to face-to-face because they would have been slavishly following the old method of getting up and going to school, spending all the time at school while sacrificing productivity in other areas where there is more potential. I must say, though, using this platform has allowed me to grow in terms of being more digitally literate, and that is the future. That is the future indeed. And when we have administrators who are stuck in the past, you know what the you know all of the potential for change now and for growth and for development, you know, that is sacrificed now. And I'm saying, well, invest in this platform, you know, maximize the potential of this platform. Don't fight it, don't clamor to go back to the past. This is the way. All right. So now, on the screen, you should be seeing that significant figures information. But I said I was going to recap this. This first question was saying 2000. And after saying, please write this, it's actually one significant figure here. And why is it so? Said last week that if the zeros follow a significant digit and there was no decimal point, then it is not significant. End of story. So therefore, this has only one significant figure. All right. Let's look at the second one. We said 50.00. And what the rule says here, the answer for this was 3. But it is 3 because what? Well, the zeros are following the 5, but then there's a point. So the 0 makes a point, then it has to be counted. So therefore, there are 3 significant figures there. End of discussion. Have any questions, post them in the comments, or otherwise contact me. All right. So if you don't have any questions, we can continue. All right. So going to the third one, where it's 0.006. And the correct answer given for this one is actually one significant figure. And the reason for that is that the zeros in front of the 6 are leading zeros, right? So the zeros can't lead. So in other words, you can't have a nobody leading significant persons, or in this case, figures. All right, again, inviting you. Any questions, your comments, just post them in the chat. All right, no. So this is the fourth one, which the number here is 4. Okay, it's actually 243.0, and the answer is 4 significant figures for that one. Again, 0 is making a point, even though it's trailing. So that's that. All right. So that takes care of this homework assignment. No, this was sent in the group last week. So, you know, students, I expect you to actually finish this assignment so that we can move on to the next topic. All right. So let's just quickly recap here. And this is amazing though. This question here, number 5 though, would be somewhat of a thing here. Where there's actually 4,050. This is how many significant figures would number 5 have? 0 here is not making a point. So we wouldn't count this 0. It's not making a point at all. It's trailing but not making a point, so it's not significant. So you know, it's almost a case like this. I mean, you know, if you're gonna buy plane tickets, do you pay for a child that's under a year old? All right. What is his age according to the law? Is he 1 as yet? No. You'll be 0 technically. So it's not counted as an individual to go on the plane. Yeah. Interesting way to look at it. But so yeah, 2 parents and a child, I'd say 9 months, you know, in their hand, is not counted as a passenger because his age is 0. Yeah, I'm saying DJ Raul keeping it cool once again. All right. So going back to this one. So we have 40, 50. And that's not the right way to call it, but it's actually that's 400 and sorry, that's actually 4,050. The correct way to call it. All right. So 4,050. What is the answer for this one? How many significant figures are there? The answer is Indeed, 3. The reason there is that the first zero here is in between. Zeros in between significant digits are actually counted. And the zero that's trailing without a point is not counted. And hence, would say 3 significant figures there. All right. So, again, remember to comment if you don't understand, if you want me to go through this one more time. Or if you have a different view, I'll also entertain that. Let's discuss it. I am not above errors, so I am open to correction. Yeah, once again. All right. So number 6 now is actually 12.060. How many significant figures are there? 0 is trailing, indeed, and 10 is a point. And you'd have to look at it in the context of an instrument. So this one, we're going to give it 5 significant figures. Let's check that on the screen. 5 significant figures. So go through the rules here. All right. Yeah, decimal point there, 0. This 0 will be counted. All right. Now, let's go through some reinforcements here. Now, we're going revising this rule about leading zeros, captive zeros, or we'll call these in-between zeros. Zeros in between numbers are always significant, according to this. Trailing zeros are never significant, or in fact, in this case, they're only significant if a decimal point is present. And their point is present here. They are significant. In that case, no decimal point, not significant. Yeah, you have to make a point. Statement has to be made. Full stop. No pun intended. Leading zeros are never significant, guys. Zeros in front of numbers are never significant. Yeah, DJ Raul keeping it cool. All right, so and let's scroll through this one now. All right, so again, more in-depth review of this one. Significant figures can be done using a set of 5 rules, and these 5 rules we discussed them last class. So for your benefit, we're gonna revise these. And zeros in front, again, our cosmetic purpose there as the 0 before the point, but then zeros. Well, okay, so we're gonna say, well, this 0 is it not trailing the point? Well, yeah, but it's not trailing that number. So, yeah, zeros leading significant figures are not significant. You remember, zeros can't lead. You can't have a child under 1-year-old, much as even 2 or 3-year-old. You can't have them lead in your house. But certainly a 0-year-old child couldn't possibly be, or it's not actually counted by society. In fact, even some children below the age of 1 haven't even received a name, much as a TRN or so, to be significant in society. That's the way to look at it. So these zeros can't lead. These zeros are not significant. And some persons in this society, they could be classified as zeros based on their ability. But not when they get into that debate. This is DJ Raul keeping it cool. All right, so now what we have here, the fourth, that's number 4. It's saying here it's significant, of course. So yeah, it's any non-zero digit is significant indeed. All right, so what we have here, significant. In this case here, 0, 0 between the other 4. So all of these will be significant using sort of purple marker to highlight that one. Yeah, in between zeros that they claim to be captive, yeah, are significant. And then of course, after the 4 there's a 5, that's significant too. But then trailing zeros here, zeros at the end of a number, and look at this now. This is crucial here. Zeros at the end, and they're actually trailing, and that's what we call trailing zeros here. Zeros at the end of a number to the right of the decimal point. Now, end of the number, all right, which is to the right of the decimal point, is significant. Full stop. All right. Any questions, comments, hit them in the description, in the chat below, or the comments section of YouTube. All right. So that's it. And we would have covered the revision there. All right. Just have a couple minutes remaining. Certainly, it's very, very much a pleasure to meet you guys here online. I wish, students would have come to class, but I'm not sure that's the case here. Trying to make it public so that no one is without excuse. This link is actually streamed in the Google Classroom group, so students who are directed to that classroom should be able to access class. Even so, if they have YouTube, if data is a problem, I'm sure that there are some plans that allow for free access of YouTube videos, and this is one of them. So this will be made available to the whole wide world. All right, so let's go through quickly. The next objective would be for us to look at measurement errors, and let's ask ourselves this question. Why do we need to know significant figures? All right. Well, at the time, you would have learned how to count back in the day, and perhaps that would have been in the basic school era of your life. Learning how to count was first, like, you had to recognize numbers. So you had to know what the numbers mean. And so you probably learned that over time. And so to the point where, if you had money, you could make the connection with the digits on it. And I don't know if you guys can remember a point in your life when you didn't know the value of money. You had coins and you had paper. And that's what it was still at the time. No, there was no value in your brains at the time. Now, can anybody remember when they first realized the value of $1, or a $5 or $10, or knew what it could buy? Hit me up in the comments and let's discuss that, because it's a concept that going throughout school we take for granted, but that foundation has to be set before we can move on. So now, in physics, however, physics is the study of materials and, of course, the energy involved in creating them and also transforming them. And so physics is that very much important. Measurement, though, is crucial, guys. In measurement, we have to be able to give exact figures, right? And according to what you're seeing on the screen here, the number of significant figures indicates the precision of an instrument. And we underline precision because precision might be a new word, or maybe it might be familiar, but the real meaning of it is not clear to you guys. Precision. What is precision? All right, I want to go to this slide here, and we're going to highlight the definition of precision. What is it saying here? The degree to which an instrument or process will repeat the same value. So again, if you're using a reliable instrument, it must be precise. So you're measuring this, for example, you're using a ruler. Let's say it's digital. You put an object in it, and it gives you a measurement. And then maybe a few hours afterwards, you go back and do the same thing with the same digital ruler, and you got a different measurement from the first time. Even though nothing has changed, you're getting a different result. That's a lack of precision. And precision means that you would be able to give me the same value. And the same thing would happen with scales. All right, so you may have a bathroom scale at home, or kitchen scale. And all right, so let's say it's a bathroom scale. I can take your mass, which people call weight, But all right, so you're taking your mass in the bathroom on the scale, and you say, okay, so this morning you woke up, you probably weigh say 200 pounds, and then by let's say 5 minutes afterwards, you forgot how much it really was. You went back again, you saw like 210. So you're saying in the last couple minutes I would have gained 10 pounds, really? In the bathroom? Whoa, gaining weight in the bathroom, that's new. But no, it's a lack of precision in the instrument, guys. That's the scenario for you to understand here. All right. So yeah. No, never mind these. These are some technical things. True value of a register is this kilo ohms actually. Kilo ohms, we use that to measure resistance actually. So I don't want to get into this. We're gonna learn more about the ohms. The ohms actually was named after a guy named George Ohm. I think it's George Ohm. Yeah, I believe he was German. So a guy that did electrical work in the field of physics. Coming back to him later on in the syllabus. But notice that with the measurement though, this is 1.35786. Lots of significant figures here, guys. And if you're counting, if I were to ask you how many significant figures were located here, you would tell me, well, 1, 2, 3, 4, 5, 6. Easy, because, well, there's no zeros, so they are significant. But what is it? Observer reads the scale to 1.4. So this long numbers, this long group of numbers, 1.35786, is read by the observer as 1.4. So if you were to write it down, he doesn't have time to write down all these digits. He's going to write 1.4. And is that correct? The question is that a right thing to do? It's a case like this. If you go to the supermarket, something actually costs $399, and you give them $400. Technically, well, should you get back change? What? $399, you get back $1. How about $399.99, and you give them $400? Or let's say $499.99. So technically, the item would, well, when you pay for it, you should get back 1 cent. But I mean, who cares? You can't go to court with that. Jamaica no longer has a 1 cent denomination. Yeah. But anyway, DJ Raul keeping it cool once again. You know what I'm saying? No pain, no gain. Yeah. But let a measured voltage. All right. So yeah, this is 6.49. Okay, so let's indicate that the instrument, and the actually it's telling you why though. In fact, before we move on to that one, 1.4 ohms, kilo ohms rather, is the rounded off value. Significant figures are crucial because what we try to do in physics is to use the least number of significant figures where possible. And there are some rules for doing that. But all right, this precision error, all right, and it's called a precision error. It's caused by a limitation of the instrument. So now notice that the observer read it from a scale of 1.4. What it means is that, all right, this could be, well, this is what is expected, the true value. So if you have the most accurate instrument, this is the measurement you get. So what you're going to understand is that significant figures equal accuracy in instruments. All right, that's why you're going to use it. So physics is about materials. So yeah, I'm learning figures now. How does it apply? You're handling instruments, guys. Significant figures, very useful there. The more significant figures you get from an instrument, it is considered the more accurate. And so when you have this to work with, and you use another instrument and get this, it's seen as a precision error. My God, this is awesome. So that's physics for you guys. That's physics. How about measurement and recording but recording things the right way, in a way that could be understood. All right, so that's that. All right, if you have any questions, guys, as we say, just are any comments? You can just post them in the group or in the of course you post them in the YouTube comments. All right, so I think that's it for today. We're gonna continue next week with more in the series. All right, DJ Raul keeping it cool once again. Stay tuned and enjoy the rest of your day. All right, go.